Classification of a garage hinges on its intended use and the activities within. To determine if the garage should be classified as commercial, let's consider several factors. Firstly, frequency and duration of non-residential activities is critical. If the owner regularly engages in automobile restoration work for extended periods, it may be considered a commercial garage. Secondly, the presence of a grease pit is an important factor. A grease pit is typically associated with commercial garages for vehicle servicing and repairs. Thirdly, the use of hazardous materials must be considered. Welding, fuel transfer, and other activities associated with automobile restoration involve flammable and toxic materials, which warrants classification as a hazardous location. Considering the factors, if the use is primarily for residential purposes, it would typically be classified as a residential garage. If the activities are commercial in nature, the space could be classified as a commercial garage. If the owner regularly uses welding and other hazardous materials, combined with the presence of a grease pit, indicates that it is not solely for residential purposes. Residential garages are not typically classified as hazardous locations under the code. However, given the commercial nature of the activities in this case, code articles may apply. NEC Article 511 covers commercial garages, repair and storage. NFPA 30 covers motor fuel dispensing and repair. NFPA 704 covers hazardous materials incident response. Classifying the garage as commercial is essential for ensuring the safety of the owner and any other occupants. This allows for proper ventilation, electrical wiring, and fire safety measures to be implemented to mitigate the risks associated with hazardous materials and activities. Considering the factors discussed, it is recommended to classify the garage as commercial for the following reasons. 1. Ensure compliance with applicable code requirements. 2. Enhance safety for the owner and others. 3. Provide a proper environment for the commercial activities being conducted. When dealing with electrical installations in a garage, it's crucial to adhere to the National Electrical Code, or NEC, which provides specific guidelines to ensure safety and prevent electrical hazards. For example, NEC Article 511, as mentioned, directly addresses the requirements for commercial garages, repair, and storage facilities. It covers aspects like wiring methods, equipment selection, and the proper installation of electrical components in these environments. NEC Article 511.3 addresses the wiring methods allowed in commercial garages. Wiring must be in metal raceway, rigid non-metallic conduit, electrical metallic tubing, or cable approved for the location. This helps protect the wiring from physical damage and exposure to chemicals or other hazards commonly found in garages. NEC Article 511.4 covers equipment above hazardous locations. Equipment installed above hazardous locations must be totally enclosed or designed to minimize the accumulation of dust and dirt. This helps prevent overheating and potential fire hazards. NEC Article 511.7 addresses sealing. Where raceways enter or leave a Class 1 location, they must be sealed to prevent the spread of flammable vapors. This is a critical safety measure to reduce the risk of explosions. NEC Article 511.12 covers ground fault circuit interrupter, or GFCI, protection. GFCI protection is required for receptacles installed in areas where electrical equipment could come into contact with water or other conductive materials. This is particularly important in garages where activities like washing vehicles or using power tools can increase the risk of electric shock. Proper grounding and bonding are essential to minimize the risk of electrical shock and ensure the safe operation of electrical equipment. All metal parts of the electrical system, including conduits, enclosures, and equipment, must be properly grounded and bonded together. NEC Article 250 provides detailed requirements for grounding and bonding. As the narration discussed, proper ventilation is crucial to remove fumes from welding. Proper ventilation is also critical for any flammable substances. A proper ventilation system ensures that flammable vapors are removed from the garage, reducing the risk of fire or explosion. The type and size of the ventilation system will depend on the specific activities being conducted in the garage and the types of chemicals being used. Fire suppression systems are also key to mitigating fire hazards. Installing fire extinguishers and fire suppression systems can help to quickly extinguish fires and prevent them from spreading. The type and number of fire extinguishers will depend on the specific hazards present in the garage. For example, a fire extinguisher rated for flammable liquids should be readily available in areas where fuel is being transferred or welding is taking place. Adequate lighting is another factor. Proper lighting is essential for safety and productivity. Garages should have adequate lighting to ensure that workers can see what they are doing and avoid accidents. The lighting should be designed to minimize glare and shadows. The use of explosion-proof fixtures will be required if this is classified as a hazardous environment. Explosion-proof electrical equipment is required in areas where flammable vapors are present. This equipment is designed to prevent explosions from occurring, even if flammable vapors are ignited. Explosion-proof lighting fixtures, switches, and receptacles should be used in hazardous locations. Warning signs and labels are necessary to inform individuals of potential dangers. Posting warning signs and labels can help to alert workers to potential hazards and prevent accidents. For example, signs should be posted to warn of the presence of flammable liquids, welding hazards, and other potential dangers. Regular inspections and maintenance of electrical equipment are important for keeping safe. Regular inspections and maintenance can help to identify and correct potential problems before they cause accidents. Electrical equipment should be inspected regularly for signs of damage or wear. Any damaged equipment should be repaired or replaced immediately. Proper storage of flammable liquids is also important. Flammable liquid should be stored in approved containers and in a well-ventilated area. The containers should be labeled to indicate the contents and the hazards associated with them. Welding safety is essential. Welding activities should be conducted in a safe manner to prevent fires and explosions. Welders should wear appropriate personal protective equipment, such as welding helmets, gloves, and aprons. The welding area should be clear of flammable materials. Regarding the classification of hazardous locations, there are specific definitions and classifications to consider based on the National Electrical Code, specifically Article 500. These classifications determine the types of equipment and wiring methods that are permitted in different areas of a facility. A Class 1 location is defined as an area where flammable gases or vapors or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. There are two divisions within Class 1. Division 1 is a location where ignitable concentrations of flammable gases or vapors exist continuously, intermittently, or periodically under normal operating conditions, or where ignitable concentrations may exist frequently because of repair or maintenance operations or because of leakage, or in which breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gases or vapors and might also cause simultaneous failure of electrical equipment. Division 2 is a location where ignitable concentrations of flammable gases or vapors are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or in which ignitable concentrations of flammable gases or vapors are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or that is adjacent to a Class 1, Division 1 location, and to which ignitable concentrations of flammable gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air and effective safeguards against ventilation failure. Class 2 locations are defined as areas where combustible dust is present. Similar to Class 1, Class 2 also has divisions. Division 1 is a location in which combustible dust is in the air under normal operating conditions in quantities sufficient to produce explosive or ignitable mixtures, or where mechanical failure or abnormal operation of machinery or equipment might cause such explosive or ignitable mixtures to be produced, and might also provide a source of ignition through simultaneous failure of protective equipment, or in which combustible dusts of an electrically conductive nature may be present in hazardous quantities. Division 2 is a location in which combustible dust is not normally in the air in quantities sufficient to produce explosive or ignitable mixtures, and dust accumulations are normally insufficient to interfere with the normal operation of electrical equipment or other apparatus, but combustible dust may be in suspension in the air as a result of infrequent malfunctioning of handling or processing equipment, or in which dust accumulations may be on electrical equipment in such a manner that interference with the safe dissipation of heat from electrical equipment may result, or in which dust layers are hazardous because of the potential for suspension in the air as a result of infrequent malfunctioning of handling or processing equipment. Class 3 locations are areas where easily ignitable fibers or materials are handled, manufactured, or used, but are not likely to be in suspension in air in quantities sufficient to produce ignitable mixtures. These locations include the following divisions. Division 1 is a location in which easily ignitable fibers or materials are handled, manufactured, or used. Division 2 is a location in which easily ignitable fibers are stored or handled. Considering these classifications, the garage that is being considered in the question would most likely be classified as Class 1, Division 2 due to the use of flammable fuels and the potential for vapors. In a Class 1, Division 2 location, certain types of electrical equipment are required to prevent ignition of flammable vapors. The electrical equipment must be designed to prevent sparks or hot surfaces that could ignite the flammable vapors. The wiring methods must also be designed to prevent the spread of fire or explosion. Wiring must be in rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or type MC cable with listed fittings. Sealing fittings are required to prevent the passage of gases, vapors, or dust from one portion of the electrical system to another. These fittings must be installed in conduit runs where they enter enclosures that contain arcing, sparking, or high-temperature devices. Explosion-proof enclosures are designed to contain an internal explosion without allowing it to propagate to the surrounding atmosphere. These enclosures are used for electrical equipment that could potentially ignite flammable vapors. Intrinsically safe systems are designed to limit the amount of energy available to ignition levels, even under fault conditions. These systems are often used for instrumentation and control circuits in hazardous locations. Pressurization involves maintaining a positive pressure of clean air or inert gas within an enclosure to prevent the entry of flammable vapors or gases. This method is often used for larger enclosures or rooms. Proper labeling of equipment and wiring is essential in hazardous locations. Equipment must be labeled with the appropriate class and division designation. Wiring must be identified with the hazardous location for which it is approved. Grounding and bonding are critical for preventing the buildup of static electricity which could ignite flammable vapors or gases. All metal parts of the electrical system must be properly grounded and bonded together. Regular inspections and maintenance are essential to ensure that electrical equipment in hazardous locations is functioning properly. Equipment should be inspected regularly for signs of damage or wear. Any damaged equipment should be repaired or replaced immediately. Considering these factors, it is important to classify the garage properly and to take the necessary precautions to ensure safety.